Okay, hey y'all. We are going to continue with our quadratic functions. This is still 3.1. We have a video finding the vertex of a parabola when it's in standard form. When our quadratic function's in standard form. I want to do one when it is in the form of ax squared plus bx plus c. So the vertex for this isn't just going to be h comma k like it was previously. What we do here for our x value, we need to do a negative b over 2a, and then for our y value, we actually plug the negative b over 2a into our function. So that's notated as f of negative b over 2a. So doing that right there is what will allow us to find our vertex if it is in the form of ax squared plus bx plus c. So here's an example. Here I have f of x equals 4x squared, a negative 16x, and a positive 9x. That is in the form that we're looking at. And what I need to do, if you look at the formula that we use to find our vertex, I noticed that I need a b and I need an a, right? So this is what we're going to do. Goodness gracious. Let's do this color. So my a is going to be that leading coefficient on my x squared term, which is 4. And then my b is the coefficient that's attached to my x term. And you always make sure to keep your negatives with the terms that they go with. And so let's go ahead and plug that in. What I get is, so I need to do my negative b over 2a. So negative, my b is a negative 16 over 2a, which would be 2 times 4. And I'm going to do my f of, same thing, negative 16 over 2 times 4. Okay, so if I solve this, what I get here is, well, the negative and the negative, that's going to give me a positive 16 over 8, comma, f of 16 over 8. But I know that 16 over 8 is just 2, comma, f of 2. Okay, so that is my x value. And then my f of 2, this right here, we plug in to find our y. So what we're going to do is we're actually going to take our function, which is our f of x equals 4x squared, a negative 16x, and a positive 9, and we're going to plug in our 2. So I get f of 2 equals 4 times 2 squared, negative 16 times 2, positive 9. So my f of 2, I have, so 2 squared is 4. 4 times 4 is 16, minus 16 squared, which is going to be a negative 32. Why did I say squared? 16 times 2 is 32. Signs are different, so it's negative. And then I have my positive 9. So I have my f of 2 is going to be, okay, so 16 and 32, signs are different. We subtract and keep the sign of the larger. Then I have my positive 9. Signs are different. Subtract, keep the sign of the larger. So my vertex is 2, comma, negative 7. Okay, So if it is not in standard form, but it is in that form, that is how you are able to figure out what the vertex is of your parabola. Now let's do this one. It says to graph. I notice that it's also not in the correct form. It's in the ax squared plus bx plus c form, but there's a few things that I know I need to identify. So if I look at my a is equal to 1, which is greater than 0, which means it opens up. I need to know my b, which is a negative 2, and I need to know my c, which is a negative 8. Okay. Actually, I don't need to know my c. I just need to, I got so used to doing like the AC method and stuff. The only thing we honestly need to know is just our a and our b. Sorry. Okay. Now we're going to figure out what the vertex is. And I know to figure out the vertex, what I have to do is a negative b over 2a, comma, plug that into my function. This is why I needed to know the values for b and a. If I do this, what I get, let's go ahead and do it right here. I get a negative and then a negative 2 over 2 times 1. And that's going to be the same thing right here. Negative 2 over 2 times 1. I'm going to move right here. If I look at my numerator on the left-hand side, I have a negative, which makes a positive. That would be a 2, right? And then the denominator, I've got 2 times 1. That's also 2. 2 divided by 2, I get a 1, comma. The math is the same inside of the parentheses here, so I get a 1. And I know from this that my x is going to equal 1. I need to solve for my y so that I can figure it out. I don't really like saying solve for y because that makes it seem like it's y equals. Let me say that again. Technically, let's just pull what we know from it, which is x equals 1. Now, in order to find my y, I need to actually plug my f of 1 in. And what I would get is 1 squared negative 2 times 1 and a negative 8, which is just 1, negative 2, negative 8. So 1 minus 2, signs are different, so you subtract, keep the sign of the larger, and then we're going to subtract 8. Signs are the same, add and keep, I get a negative 9. So this is telling me that my vertex is 1 comma negative 9. I can go ahead and plot this. So I scoot over 1 on my x-axis and I go down 9 on my y. That puts me right there. Okay, so I know that my line of symmetry occurs on a vertical line at the x-axis, and it actually goes through the vertex. So that tells me that I am symmetric with respect to x equals 1. I'm going to go ahead and do my line of symmetry. I'm going to try to see if I can just highlight it. Let's see here. I can't draw a straight line to save my life. I did that one fast. Okay, so that's my line of symmetry. Symmetric, okay? They match. They're both blue. Okay, my shaky line. Okay, so what else do we need to know? Well, in order to graph this, we need the x-intercepts, we need the y-intercepts. So let's go ahead and do those. Move this over here. For my x-intercepts, I hate having my pen look all thin. I'm going to come right here, y'all. So to find my x-intercept, I know that I need to set my function equal to 0. So I would have 0. My function was x squared negative 2x negative 8. That is a trinomial. It can be factored using the AC method or this method right here. I know I have x's. I know that, okay, so they need to multiply to give me 8 and add to give me 2, 4 and 2. The larger would be negative because if you FOIL this, I get, I would have a negative 4x and a positive 2x. Those would combine together to give me a negative 2x. And then if you just look at your last terms, I would do 2 times 4 is 8. Signs are different, so it's negative. So this tells me that my x equals negative 2 and my x equals 4, which means my intercepts are negative 2, 0, and 4, 0. Negative 2, 0 puts me right here. 4, 0 puts me right here. And then to find my y-intercept, I actually plug in 0 to my function. So I would get 0 squared, then a negative 2 times 0, and then a negative 8, and then 0 squared, and then the 2 times 0. So what I have, let me do this. This is me plugging in 0, y'all. So what I have is just negative 8 is what I get when I plug in my 0 to my function. And that point would be 0, comma negative 8. So you do not move on your x-axis, which is why it's a y-intercept. And you go down to negative 8, which would be, whoa, JK. Right here. 1, negative 2, negative 3, negative 4, 6, negative 7, negative 8. It's kind of weird with the way the numbers and stuff are because the numbers are bigger than the space allotted. Okay, so what do I have here? Oh, sounds like the kid's coming back from the park. Negative 2, 0, and I've got a 4, 0, and then for my y-intercept, I got 0, comma negative 8. So I'm going to be asked, of course, what my domain is. Look at your function. What is your function? It is x squared, negative 2x, negative 8. That is a polynomial. It is all real numbers because it's going to actually include all of the values on my x-axis. And then for my range, that is all of my y values. I haven't graphed it yet, so I can do that first. Okay, I can do it, y'all. Let's see. I don't know why I can't have like a really cool little interactive tool here. So we're going to stop. Just do it. Oi. I can't touch it with my arm. Best one ever. I win. So now range. Y values. Start at the bottom with your pen. I have mine like laying flat, like horizontally, and I move it up. I'm only concerned with my y-axis and moving up. I notice that it starts its lowest point. It's right there on my y. That is at negative 9. And we use a bracket, negative 9. It goes up forever. Okay, so this is an example of graphing a function that's not in standard form. You're just going to use the formula that we know to find our vertex that gives us our x then we're going to plug in what we need to the function to be able to find our y. With the x and the y, you have your vertex. Having your x coordinate gives you your line of symmetry. And then we know how to do the x-intercepts, and we should know how to do the y-intercepts. And then we know that the domain for all polynomials are real numbers. It's your range that'll vary based on the actual graph that you draw. Remember that if a is greater than 0, it opens up. If it's less than 0, it opens down. There's 2 more concepts that we have to cover in the same day. So it'll be 4 videos, though, I think. If you have any questions, y'all make sure you ask me and let me know. Thanks. Bye.